So what is maximum and minimum? The terms maxima and minima, can you read this? Terms maxima and minima refers to the maximum and minimum values of a function respectively. When analyzing the behavior of a function using its derivative, we often look for critical points where the derivative is zero or undefined. So when the derivative can become zero, just imagine when the slope is zero, right? When the slope is zero, so either the function is always having a same slope of zero or it's a varying function like this, right? So at which points it can become zero is at a point where it is having a crest or a peak, right? So from the crest, it has to either increase or from the peak it has to decrease. That means at the peak it will have a maximum value, at the crest it will be having a minimum value. That is the reason at any maximum or minimum values dy by dx will be 0. Okay, so that's what the basic logic about this. Okay, but further to it this doesn't say it is maximum or minimum, it may be either maximum or minimum. That's for sure. At that local place. Okay, that's why it's called local maximum or local minimum. It's not completely throughout the function, but in a particular region, this may be locally true. That's why it's called local maximum or local minimum. Further, let's see what is there. Let f of x be a differentiable function in an open interval containing a point c. Then, if f dash c is 0, and what is this f double dash? That is second derivative d square by dx square. If this is less than 0, that means the function has a local maximum. Why? Because if you further differentiate, the function is decreasing. As the function is decreasing, that point C will be what? Maximum point. Geometrically, at the local maximum, the function changes from increasing to decreasing. That is, it would have been increasing, at that point it will decrease, right? Similarly, local minimum is at the minimum also we'll have dy by dx 0, but now d square by dx should be what now? Greater than 0. Then what will happen? At the critical point it will be decreasing and further it is increasing. So with the help of a double derivative or secondary derivative, we can confirm whether it is increasing or decreasing. But with the help of single derivative or first order derivative, we can only conclude it is either a maximum or minimum. But with the second order derivative, we can confirm whether it is maximum clearly or minimum clearly. Okay. Suppose what if the second order derivative is also 0? The second order derivative is also 0. Then it says the function is neither increasing nor decreasing. The function is a constant function. Okay. So as simple as that. See how we can use this concept to understand the nature of the curve. So simple differentiation will help us to understand the nature of the curve itself, right? Yes. So you can read this part again quickly. So critical points. What are critical points? The critical points are the points where the function is changing its direction from increasing to decrease or decreasing to increase. Okay. So if f dash is 0 and f double dash, that's double derivative is 0, then it is undefined. I just now told you. Then it's undefined or inconclusive. Okay. And wherever that change is happening, that point is called critical point. So first derivative test, the theorem, these theorems you can go through. Right. So can you please read this theorem quickly? The theorem says if f dash x is 0 greater than 0 to the left of the critical point and f dash x is less than 0 to the right of the critical point. So let's say critical point is here and you're differentiating it. So when you're differentiating it, here it is greater than 0 and here it is less than 0. That means that critical point is what? Maximum point. Similarly, at the left of the critical point, if the f dash x is negative and the right of the critical point, f dash x is positive, that means the critical point is what kind of point? It's a minimum critical point. Okay. The first derivative test helps us to understand the nature of the critical points. It is minimum or maximum. Okay. Yes. That's one way to find out is it minimum or maximum. For this, what we need to do, we have to have a, it is simply, we have to find out the differentiation at multiple points, right? This dy by dx one time is not enough to understand this way. If you are using only first order derivative, you need to have multiple differentiations at the point to the right hand side as well as the left hand side. But with the help of a second order derivative, only one time is enough because it will tell us whether the change is happening in positive direction or negative direction, right? So it's a simple logic and it makes sense if you get the logic right. Okay. That's what we are discussing again. With the second order derivative test, what we do is f dash has to be 0 and f double dash has to be greater than 0. Then it is local minimum point. And the other way around, if it is f dash is 0 and f double dash is greater than 0, it's going less than 0, then it's going to be what? Local maximum point. That is, if double dash is increasing, okay, it is increasing, so minimum. If double dash is decreasing, then it is maximum. Okay, so look at this. If f dash double dash is greater than 0, then we have a minima. If f double dash is less than 0, we have a maxima. And if f double dash is 0, then it is going to be what? It is second derivative test is failed, so we cannot conclude is it maximum or minimum. That's what it says. Questions, let's try to solve them quickly. Some questions we don't need differentiation also to understand are they increasing or decreasing or the range if you know the function very well. So let's do in both the methods. One is by general understanding of the graph, how it is. What is a curve? F of x is equal to what? 5 plus sine 2x. We know sine curve, right? So sine curve is between what? -1 to +1. So sine 2x always lies between what? -1 to +1. Now I need to add 5 on both the sides to understand the range. So what is this? This will become +4. This is 5 plus sine 2x less than or equal to 6. So what is the question now? Find the minimum values and maximum value. So the minimum value of this function is 4. Maximum value of this function is 6. By using differentiation, what happens is f dash of x is equal to what? 0 plus what? Sine 2x is what? Cos 2x into 2, right? Yes. And what I should do? I should equate it to 0. If I have to equate it to 0, so what will happen is, and I need to do the double dash also, right? So double dash has to be positive. So let's come to that later. For single, this is going to be 2 cos 2x is equal to what? 0. That means cos 2x is 0. Cos 2x is 0 is what places? At 0 degree as well as, no, cos 2x is 0 at 90 degree as well as 270 degree, right? So at 90 degree, what happens is sine 2x. Sine 90 will be 1 and sine 270 will be what? -1. Look at this. At sine 90, it is 5 plus 1. 5 plus 1 is what? 6. At sine 270, it is 5 minus 1, which is 4. That means our answers are verified, right? Either by differentiation as well as with a difference. We don't have to think about maximum or minimum because we did not even do the second order derivative test. With the first order derivative, we equate it to 0. There are two values, and one value will give you maximum, one value will give you minimum, right? Yes. So there are two ways. One is understanding the curve, but as it is coming under application of derivative chapter, we have to use the differentiation concept to show the maximum and minimum to get the full marks. Remember that. Okay. Yes. Let's go to the next one. Yes. So I hope the question is visible. Yes. What is it? A volleyball player serves. It's a case study question. Remember, case study questions might have too many informations, but it is very easy if you understand the exact purpose of the question and the informations. Okay. So the question says a volleyball player serves the ball which takes a parabolic path. Okay, serving a ball, and when he's serving a ball, he is just serving, and when he's serving the ball, it takes a parabolic path. Okay, so That's a curve, right? And that curve is given by this equation minus 7 by 2. How did they get this equation? Don't worry. We just need the equation with a story. That's what the story is all about. Plus 1. Okay. And time is either 0 or positive. Okay. So what is the first question? Is h of t a continuous function? That we are not going to discuss in this chapter. We are going to talk about only the find the time at which the height of the ball is maximum. If the height of the ball is maximum, first thing is the differentiation with respect to time t has to be 0. Okay, and then verify double dash of this is greater than 0, right? To be maximum or less than 0, right? That's what you have to check. What is this differentiation of this? When you differentiate this uh, with respect to time, we get minus 7 by 2 into 2t plus 13 by 2 t equal to 0. So when I differentiate, this will be cancelled. Am I right? Are the values correct? Yes. So if you differentiate this, what we get is, yeah, this is going to be t. So what is t now? Minus, it becomes 7t is equal to 13 by 2. So t is equal to what? 13 by 14, right? But is it maximum or minimum? How to find out? I need to do the second order derivative test, right? So when I differentiate this further, what we get? So when you differentiate this further, what I get is, I'll just directly get minus 7. That's it, right? So I get only minus 7. That means it is negative. Yes. As the second order derivative is negative and first order derivative is equal to 0, we get the maximum value, and that maximum value is correct, which is 13 by 14. Right? Yes. One more question quickly. Minimum value of this expression is c minus b square. What is the expression given here is x square plus 2bx plus c. So first we have to differentiate this and then equate it to what? 0, right? So correct, right? So when you equate it to 0, what happens? Equate it to 0, we get 2x is equal to minus 2b and x is equal to minus b. Okay, so if we have to differentiate this again with respect to x, so what we get is 2. Okay, this is greater than 0. As it is greater than 0, we have got the minimum value. Okay, at minimum value, what is x? X is equal to minus b. If you put minus b in the equation, what we get is b square minus 2b square plus c. Yes, what they're telling is correct. That means assertion is correct. So assertion is correct. What about the reason? The first order derivative of the expression is x is equal to minus b. So is it related to this question? Yes. That means what? Both the assertion and reason are true, and R is the correct explanation of A.